Hello, my name's Max McMillan, and with the help of my sister, I'm going to demonstrate how you can find out how tall that electric pole is using two measurements of length and one of degree. So, first off, down there at the base of the telephone pole to my sister's feet is 20 feet. From her feet to her eyes is 4 feet 8 inches, which is 56 inches. 58.
58 inches.
What?
58 inches.
58. Okay. I forget stuff easily. And so, can you measure
What am I supposed to do?
with a clinometer?
What's a clinometer?
Use it.
A clinometer is basically a protractor with a scope on the flat or the straight edge. And the scope is the straw. And can you stop? Okay.
And what she's supposed to do with that?
A clinometer allows you to measure the angle from whatever you're measuring. It allows you to find an angle of height. An angle from where you're looking at to something taller than you. I don't know how to explain it.
And the end result is what?
A degree. After using mathematic ratios, the end result is height.
Oh, okay. So what does she have to do with that thing?
She has to look through the straw to the top of the electric pole. Which was pre-measured to be 36 degrees. You can stop.
Okay.
So, knowing that that was 36 degrees, or that angle was 36 degrees, and using the tangent ratio and a right triangle, because, well, that's close enough, and also knowing that from her feet to the flagpole is 20 feet, which is the adjacent angle, with from where she was looking to the top of the telephone being the hypotenuse, and the telephone pole's length being the opposite, not angle, opposite side. So using the tangent ratio, which is the opposite side over the adjacent side, and solving for x, it would be tangent this. It would be tangent 45 equals x over 20, because x is the height of the telephone pole and 20 is from the base of the telephone pole to Cali. And so you just do that backwards and multiply tangent 54 by 20 feet. You get that from Cali's eye level to the top of the telephone. What? No.
Oh, okay.
From her eye level to the top of the telephone pole is 25.5276 feet. And then, because, here, because from technically, we measured from here, or, well, it would be technically right about here to the top. You need to also add how tall my sister is from her feet to her eyes, which was also pre-measured to be 58 inches. So you also have to add that in. And when you add that in, you end up with 32 feet, or 32.3609 feet, which is rounded to 32 feet.
And that makes perfect sense
Because when actually making a telephone pole, they're anywhere between 30 to 60 feet.
30, 40, 50, and 60 feet. And they bury them.
And they bury them however many feet
8
in
feet
the ground.
deep.
Oh, 8 feet deep.
So that would be
A
30
40-foot telephone pole from the actual base, which is currently 8 feet underground, to the top of the telephone pole.
Very good. Yay.
Yay.
Produced by
Tina McMillan,
Tina McMillan
Max McMillan, Callie McMillan.
and Cathal and Finn.
Yes. Our lovely dogs.